What's up, dudes? Imagine being able to type this fast but not being able to win contest. Omega lul. Okay, so 3 more minutes. And then we'll check the solutions. How did you guys enjoy the contest? Did you do well? Did everything go as expected? Yeah, those weren't so bad, right? Like the worst one was the second one. I was like, this is supposed to be easy, right? Like I spent the majority of my time on that one. It was so stupid. Yeah, definitely. There is another question on this site that is a variant of it. I'm gonna wait 2 more minutes before going more in depth into it. But yeah, definitely some shady stuff going on around here. Oh no. Well, it kinda is like that, but like nearest neighbors. But not really. What's K means? Not to be confused with K nearest neighbors, okay. Okay, so it's like a fixed number of clusters, while in this case we could have like any number of clusters. The constraint was the distance between the points. Okay. And you're trying to minimize the mean. Oh, that's cool. But yeah, definitely out of the scope of this contest. That would make for an interesting, harder question, I think. Okay, so contest should be over. GG. Okay. So let's advertise a little bit more. Okay, so this one, TV shows. So I think this one wasn't that hard. The only thing was like you needed to read the question correctly to see that like some movies came like twice, so you had to first iterate over each pair and like group them together if they had the same title. So yeah, for my solution I'm doing exactly that. So I'm zipping the shows and durations together to form pairs of titles and duration. And for each unique title I'm incrementing the duration. And after that you can just sort based on the duration. And take the sum of the k longest movies, or movies that were broadcasted the longest. Yeah, I think like those types of question where you have two separate arrays of the same length are like made to be zipped. But it's like a small detail. It's only for style points. Just use a counter. But you have to combine. How did you use the counter? Oh, right. To increase the quality. Not like maybe I could plug my internet. Am I dropping frames? No. But I know that I can't increase my quality because I have a shitty laptop. But what I can do is zoom the browser. So I'm gonna do that. If I can. Okay, I'm gonna. Okay, is this better? It should be right. So it's like taking the k largest numbers out of an array. But first you need to combine the number belonging to the same titles. You can do so using a dictionary. So optimal space complexity, I guess. It's pretty as simple as it gets. Exactly your solution. Yeah, there's not much room for variation on this one. So the next one is where it gets trickier, I think. Okay, so this one I spent at least half the contest trying to solve it before like realizing that it's almost the same as an other question on the site, which is the cinema one. I'm not sure that if that's the title though. Or movie theater. Movie theaters. So yeah, this one is medium. And it asks you the minimum number of theaters required to be able to show all movies. So basically like the maximum number of movies running at any time. So this question is actually simpler than the one asked during the contest, but it's a medium, so that's quite interesting. But the logic is the same if you look at this one. It's like you spread out the intervals into the starts and the ends. I'm gonna go back to the contest first. So yeah, instead of treating intervals, you want to be able to like iterate over the starts and the ends. So that way, each time you encounter a new start, you increment your running count of simultaneous intervals in that range. So basically, each time a new interval starts, it's gonna add a new overlap, so the number of intervals in the same range increase by 1 if we look at the questions. So each time the number of intervals intervaling over a certain range changes, well, you add a new interval in the output. So each time you have a new start or a new end, well, you have to add a new answer to the output as well. So to keep track of the number of intervals at a certain time, You just do +1 each time there's a start and -1 each time there's an ending of an interval. And eliminate the ones where the running count is 0. So, is that clear enough? Is it a good explanation? Because yeah, it was really tricky, and I tried a few things before trying this solution, and it ended up working out. Oh yeah, and I forgot to mention that you sort them as well, so it's easier to keep order of things. We can treat start of intervals and of intervals separately. Alright. Each time a new interval starts, we increment a running count variable, and each time an interval ends, we decrement it. Each time the running count changes, we commit the state, the answer array. Okay. Yeah, sure, I can turn off the music if you don't. What number? This is number 2. The hardest question of this contest. Okay. So yeah, each time, basically, for each event, the next one is either gonna be a start or an end, but in either case, it's gonna change the number of intervals in the current range. Either it's gonna become +1 or -1. So that's why we can iterate over each event. And if it's not equal to 0, and in this case, t is not equal to last, I guess it's for empty ranges that I added this case. Like if one interval ends at a certain number and another one starts at that same number, it's like gonna give an empty range if you don't add that case. So be careful to eliminate empty ranges and ranges where the running count is 0 separately. And optimal time complexity, well, it's n log n if I'm not mistaken, because there's a sort here, but we sort the start and the ends, so the array is going to be 2n, but since it's only a coefficient, we can ignore it. And then we do another iteration, so yeah, n log n. Not sure if we can do anything better for this. Maybe, so I'm going to leave it open as a challenge. Okay, so is it clear for everyone? Does n log n is best? If you say so, I trust you. Okay. What's a similar problem? What do you mean? Are you talking about the problem I mentioned earlier? Yeah, if you want to practice something simpler, I think movie theaters. Uber pool. Social can shit on us if he wants to. I think he deserved that right. Yeah, this is basically like the inverse of the contest question, which is interesting, but I think it's simpler because you just have to keep the running count, and if it ever busts, you return false. Okay. So, third one was kind of tricky as well, because you had to deal like not only like if you only already saw a node, but you had to have some context on how you saw a node, because like I think I should draw this one out. Okay, so let's draw a tree. Okay, so let's say we have a tree here. And like one last node here. And okay. So let's say we start on the root node here. Like when we explore this node right here, like if you look at this neighbor, like the root node, you can know that it has been seen, but you don't know by which node it has been seen or in which way it has been seen, like if you explore it. Because let's say you have like a diamond like this, like you explore the root, but then you like go around and explore it again, but by the other side. Well, you have no way of knowing by which way you have seen it. So like the problem is like getting rid of this directionality. So the way I solve this problem is like each time you use a path, basically you remove it. So you're sure that if you ever see the same node again, it's by a different path, and that breaks the rule of trees that you have only one path leading from one node to the other. So here I have the basic rudimentary operation of building the adjacency list. So I iterate over the edges and add E as a neighbor to S and S as a neighbor to E. And I add every node to a set that I can iterate on after. And then that's what I do. Here I iterate over each node. If I haven't seen it, I try to do a BFS on it. And then I do BFS. So here I check if the node has been seen, the neighbor. I return false because it means it has been seen and not by a direct neighbor, because each time I visit a neighbor here, this is the most important part, is I remove the current node from the neighbors of the neighbor we're gonna visit. Basically we break the edge for both nodes. So that's why I use the set for the neighbors of a node instead of a list, so I can easily remove the nodes like this. And there we go. What do you guys think about this question? Did you have trouble with it? I think that was the main challenge. Will I be saving this stream? Well, there's always my VODs. If you think it's worthy for me to highlight it, I can. I could start uploading them to YouTube, but like you mentioned earlier, I'm kind of concerned with the quality since I'm doing it on a shitty laptop. So I was considering maybe I should buy a good PC, but that would be quite an investment. But if you want to donate me all your money, I would be happy to. I'm just kidding, by the way. Yeah, I should. Yeah, Square. I'm still awaiting their response for my second offer. It's been so annoying with all this COVID situation. Thanks, man. I appreciate it. Okay, so let's put it into words. So, to validate, we have a forest. We can use the rule that 8. What's wrong with my solution? Is it all the like the spacing between functions and everything? Well, every new line you add is an extra keystroke you have to do. One path between every node. Way to validate this is to do BFS unexplored node. Each time you visit a neighbor, you remove the edge between them. If you ever fall on a node you already explored, is then one path to this node. And so this is not a tree dot. So is this optimal? I'm doing set copies. I think everything is in order of the number of nodes. We use sets everywhere, so everything should be in constant time for that. I think so. Space complexity. I use a lot of sets. Maybe not. Not sure. There you go. Okay. Last question. What's up, Baxter? Okay. What's the question? So, did you do the contest? Right now we're gonna tackle the last question. That was very interesting, to say the least. So basically the problem is like, you want to have the minimum number of groups where every point has a maximum distance of k between at least one other point in the group, if that makes sense. So here's how I did it. I iterated over every point, and if I never seen it before, it means it doesn't belong to any other group. So when that happens, I put this point into a queue, and then basically I iterate over every other point in the list of points, and for every point that is within the correct distance, so here's the Euclides. Yeah, it's totally not a k-means clustering. I know there's a k and there's clusters, but it's not k-means clustering. It can be tricky. Reading is hard, you know. Okay, so yeah, basically for every point that has not been processed before, we iterate over every point, and every point that is between in range of the current point, so in the range under k, we add it to the queue, and then we process every point we added in the queue until we run out of points in the queue. So it's kind of like BFS, where each neighbor are the points that are within distance, but the thing is you don't know the points that are within distance without iterating, at least with my solution. So this one is, I'm not sure if it's n squared, since I guess if every point is like apart by k, you have to do n squared, so it would be n squared. So since, actually, is it worse than n squared? Maybe it's even worse than that, because each time you add a point in the queue, you iterate over every point. So I'm not actually sure what the time complexity would be in this case. So yeah, I think the main idea here is like a dynamic BFS, where you have to iterate over each point to find the neighbors, and you don't want to process the neighbors you already seen because they're already placed in the group. So when you exhaust all the points that can belong to the current group, well, you add the current group to the list of groups, and then continue iterating over the rest of the points to see if there's any point that you haven't processed yet, using the scene set to know if you processed it. and then you return the number of disjoint groups. Ta-da! What do you guys think of this one? Did you think it was easy? Curious to see the other. Union find. Yeah, that makes sense. I don't even know how union find works, but let's compare the times it takes. Okay, it's kind of in the... Yeah, right, it's kind of short, 50 minutes, but I think that's the point of like training to go fast on like quote unquote easier questions. So when you're in harder tournaments, well, you can breeze through those questions. Yeah, true. It's almost as hard as Cold Forces at this point. But it's fine. I think as long as we're having fun, right, guys? You're having fun, right? Okay, let's pause this. It's been my pleasure. Don't forget to subscribe and like and do whatever. Okay, so to BFS in some ways, we iterate over every point. We iterate over every point, and if it's within distance, we add it to a queue. Then we repeat the same process for every point in the until the queue is exhausted. At that point, we have disjoint group. Push-up reveal at 2 million subs. You'd be surprised. I can do a handstand clap push-ups. I managed to do one. You guys would be impressed. I swear. So optimal, I'm really not sure here. I'm not even gonna try to guess. Swole as fuck. Okay. There we go. You have optimal? 1,600. That's quite suspicious. Let's see it. So you transform the points into tuples. This is the distance between 2 points. Oh boy, okay. So for every point, you look at the points after it. Then you check the distance. Oh boy, I'm not sure I can understand what's going on. I mean, if you want to hop on stream and explain it, I'd be more than happy to invite you. You're fusing real groups. Okay, so you're continually like combining arrays. I can see why it's not that fast. Okay. Makes sense. Alright. Unless anyone has any more questions, I think I'm gonna go to sleep now. It's been a pleasure, and I guess we'll do the same thing Bunny's approach. Yeah, I look at it with a clear mind. I guess we can do the same process for the next contest if Alex isn't there. Let's hope so for my views. All right. Thank you guys. See you next time. Bye bye.